Okay, last time we have seen about the difference between scalars and vectors and some practical application of scalars and vectors. Today let us see the kinematics, dynamics, and the force. First, let us see the force. What is force? So force is what? Force is something that pulls or pushes an object. ኃይል ማለት አንድን ነገር የመግፋት ወይም የመጎተት ተጽዕኖ ነው። ስለዚህ the force is denoted by what? F, okay? The force is denoted by F. So we can say that force is something that pulls or what? Pushes an object. So we can define as force is okay, what is the SI unit of force? The SI unit of force is Newton, because the first person that discovers about the concept of force is Isaac Newton. So the SI unit of SI, System of International Units, force is what? Force is, it's what? It is it's Newton, okay? It's Newton. Now, they have three laws of Newton. These are what? Newton first law of motion, Newton second law of motion, and what? Newton third law of motion. Let us see the first one. Newton's first law of motion. ስለዚህ ኒውተን ሶስት የራሱ የሆነ ህጎች አሉ። የኒውተን የመጀመሪያው ህግ፣ የኒውተን ሁለተኛው ህግና የኒውተን ሶስተኛው ህግ። የኒውተን ፈርስት ሎው ኦፍ ሞሽን ወይም የኒውተን የመጀመሪያው ህግ ምን ይላል? ስለዚህ ኒውተን ፈርስት ሎው ኦፍ ሞሽን ስቴት ዛት ኢፍ ዮር ቦዲ ኢዝ አት ረስት ኢት ኮንቲኒው አት ረስት ኢፍ ዮር ቦዲ ኢዝ ኢን ሞሽን ኢት ኮንቲኒውስ ኢን ሞሽን አንለስ አዘርዋይዝ ዋት unbalanced or what external force act on the body. So this states that if a body is at rest, unless otherwise unbalanced. Is act on the body. Okay, so if there is no external force act on the body or the object, so the force or the total force or the summation of all forces, this is equals what? This is equal 0. If what? If there is no external force. Okay, the next one, let us see Newton's second law of motion ወይም የኒውተን ሁለተኛ ህግ የምንለው ነው in Amharic. So okay, Newton's second law of motion states that the acceleration of an object is directly proportional to the force and inversely proportional to what? The mass of the object. That means A is what? A is directly proportional to the force and inversely proportional to what? The mass of the object or the mass of an object. So this tells us about the proportionality. So in order to change this proportionality to equality, there must be what? There must be a constant. This constant is K. The value of K is what? 1. What's K? K is a Newton's constant. So A equals what? A equals K F over what? M. In this case, what is the value of K? The value of K is a constant. It is what? K equals 1. So A equals what? Force over what? Force over M. That means the acceleration is directly proportional to the force, but inversely proportional to what? The mass of an object. So in this equation, we can find the force. Just multiply both sides by mass. The force equals what? It is mass times what? Mass times acceleration. This is what you call it, Newton's second law of motion. So in this case, remember, in numeric, what's acceleration? Acceleration ሽምጠት የምንለው ነገር ነው አይደል? እንደ acceleration means it's the time rate of what? The time rate of change of velocity, okay? If the velocity, the initial velocity and the final velocity and the time is given, so we can find the force by what? Force equals what? Mass times, in this case, acceleration is the time rate of change of velocity, therefore, change of what? Change of V over what? Change of T. That means V final minus what? V initial over what? T final minus what? Minus T initial, okay? T initial. So, force equals what's acceleration? It's change of V over change of T. So, we can use this one. If what? If the velocity and the time is given, okay? Change of T. If the mass of an object and the acceleration is given, in order to determine the force, we can use what? We can simply apply this formula, this simple formula. So this is what you call it, Newton's second law of motion. And the third one is what? Newton's third law of motion, okay? Let us see. Newton's third law of motion. Newton's third law of motion states that action and reaction are always equal and opposite, okay? Equal and opposite, okay? Action and reaction. For example, if I push this object, there's what? There's a force that pushes my force, okay? So action and reaction always exist in the same plane. Or action and reaction, they are always what? Opposite direction. So we can define that Newton's third law of motion, action and reaction are equal. Okay, so that means when I will pull this one, there's something that pushes. So my force in this direction, it's the action. There's also what? The reaction, okay? There's the action, there's also the reaction. This is what you call Newton's third law of motion. This is all about today. The next one, we will discuss about some practical application of Newton's second law of motion. So if you have any question, please leave us a comment. Thank you and have a good one.